All right. Good morning, everybody. Today is Friday, February 23rd, 2018. And this is Before the First Cup with Jules here on UCVI.tv. Happy Friday, everyone. It is a chilly 39 degrees, overcast, and going to rain here in upstate New York. So where do we leave off on Wednesday? We titled the show Stem Cells, Chimeras, Drones' Nose, BioComputers, Logic Gates, and DNA. And we had spent a couple shows looking at how they were utilizing biology to program and turn them into little mini computers to be able to do all kinds of things inside of you, including produce pharmaceuticals. They're using DNA for storage, and now DARPA's looking at using DNA as an image search engine. Then we just saw Microsoft is working on making a DNA file system, which is pretty weird. You can go in and find one file instead of sequencing the whole DNA strand to find your data. And as they are progressing forward in this biological takeover, we saw the very last story was titled Graphene Shown to Safely Interact with Neurons in the Brain. We've talked about them creating brain-like computers, these neuromorphic machines that are going to be able to work more like human brains. They have been garnering a lot of information about how brains work through medical scans and different electronic devices that they utilize in our healthcare. Now, as we've looked at this Internet of Things and this rollout for 21st century medicine, we've discovered that more and more of it becomes intrusive. Of course, it's going to cure you. Step right up. It's going to bring the cost of healthcare down. Well, some of the things I want to look at today is healthcare. Some of the things in healthcare, the FDA, which that 21st Century Cures Act was supposed to get out of the way, the pesky FDA that was watching for your safety has been standing in the way of medical innovation. Well, I want to look at something today that I've kind of looked at a few times, but a new story came to my attention yesterday that made me start digging into it again, and it really angers me because I was at the receiving end of this again. The pesky FDA that held back to keep me safe, even with their holding back, didn't keep me safe. Or a lot of people, it seems. And I think we should take a look at some of what I've uncovered. So we've been looking at them utilizing living cells, typically stem cells, to turn them into other things, maybe even a replacement organ for you someday. We had even seen them creating neurons and putting them into drones to sniff out explosives. That was a story we read Wednesday. Well, I guess let's go here. Maybe, I don't know. Hold on. I'm trying to get back to my old ways of doing things. You know, let's put it this way. So over the last couple days, I'd say over the last week, I've been fighting the flu. I still feel a little bit flu-y right now. But we've also been trying to finish our article on 5G, which has been kind of painful. Trying to work on this when you're not feeling well isn't very good. And it is mid-season break for the kids this week, so it's kind of been a lot of zippity-zapping of my concentration. Not feeling well, wanting to go lay down, having to have this deadline we're trying to write, and then having to deal with the family life 24/7. It's been very difficult. Now, not to say that it wouldn't typically be very difficult, but I've been finding, and I mentioned this a few weeks ago, that since my incident this summer, when I had my stroke, it has become very difficult, it seems for me, to multitask. And I've been noticing that there's been a little bit of a decline in my cognitive capabilities that I once had before. And you could be saying, well, Joel, you're starting to get a little bit over the hill. Well, yeah, maybe that's true. But on the other hand, the evidence is in my replays. And when we've been playing these replays, I catch some of them sometimes. I got to say, I can actually hear My brain used to work a lot better than it has been recently. So I came across this story yesterday that really caught my attention because at some point I might find myself in one of these machines just because of the alternatives. Potentially now they came out and they said, whoops, you know how we've been recommending this treatment all this time for all these people? Well, it might be causing some brain damage and some kidney damage, and it's probably not flushing out of your body like we said it was going to be. That's that gadolinium, I think it's called gadolinium, which is a contrast dye that they give you when you get into an MRI machine. Typically, they put you into an MRI for many different reasons, but in the case of my illness, they put me into an MRI to take a look at the blood flow in my brain. And in order to do that, they have to give you contrast, or so they say, to be able to see in detail. And we have some of these new high-resolution, artificially intelligent MRI scanners coming from companies such as GE, and maybe that'll change this fact. But up until this summer, they typically had to give you the contrast dye to get a high-resolution image. Well, listen to this, because I was supposed to be going for another scan a few months ago. My neurologist, who I have to say has not ever checked up on me to see how I'm doing or to ask me any questions to make sure my brain is still functioning properly or I haven't run into any future issues. My neurologist wanted to do this MRI scan, which was not only a blood flow scan, but they wanted to give me some sort of medication that, of course, they said had no long-term side effects. Yeah, like I believe that one. Until I started to look into them, of course, and I found out there's all kinds of things, and you could even die from the procedure, but no, we're not going to mention that one. But this MRA that they wanted to do, they'd be giving me some sort of drug that would cause all of my arteries and blood vessels to expand, and they would use this contrast dye and this magnetic resonance imaging to be able to see how far my blood vessels would expand. And that would be just in case at ever some point in the future that they would have to go in, put some sort of shunt or something in there to keep a blood vessel or an artery open. Well, they asked me if I was allergic to the dye, and I said, well, I had some issues before. The last couple times I've had an MRI, I had this weird swelling right at my jawbone. And upon researching that after I got home, I discovered that that is where your parotid salivary gland is. And typically, after an MRI and getting that contrast dye, that could show that you have a sensitivity to the chemicals that they're putting into you. And it looked pretty horrible. Every time I'd eat something and my salivary glands would start working, they would swell up. It looked like someone punched me in the side of the face. It was pretty horrible, and they hurt pretty bad. So he said, no, I have a little bit of an issue. And they got kind of mad at me at the neurologist's office. Didn't tell me that they then canceled the scan, and no one has ever followed up with me since that time. So we don't even know if the blood flow in my brain is working properly. That's the horrifying part. And that's where I get pretty angry about how broken our healthcare system is. You know, how many people get sick? I have a neighbor at home who ended up with some weird sarcoma on her leg, and then it spread, and now it's in her lungs, and she has nobody to help her. So my mother takes her to her appointments and stuff. Her husband's working. Her son is working, so there's no one really around. And my question is, why do they not have some sort of caseworker? Because I could tell you, even from a perspective of somebody in the ICU who was putting their pants on one leg, like a day after my incident, and they were all kind of amazed that I had that kind of balance still. I am still surprised that after you get out, there's nobody that is keeping an eye on you or making sure you're still feeling all right or making sure that your mental state is okay. You know, and of course, when you get back into your family life, things don't go away. So if you had an obnoxious kid, prepubescent kid before you got sick, well, you better damn believe it that you're still going to have an obnoxious prepubescent kid when you come back. And that kid's probably not going to be too happy about the fact that you were sick. And they very well may not play along. We're trying to be helpful. So this adds and compounds upon the issue of not feeling well and trying to recover. But you don't have anybody checking up on you, and even your primary care physician. I'm going to say, even though I was lucky to have someone who kind of got it, and it was actually the physician's assistant who did all kinds of research to understand exactly what I had going on, they are not beyond being part of this corporate medical system that is happening right now. It's all about profit. And their division that they worked for as part of this healthcare conglomerate got sold. So now my doctor, who used to be 15 minutes away, and it really wasn't that big of a deal to get there, is now way on the other side of town. And they sent me a really nice letter. The company that sold them sent me a really nice letter when they were selling them saying, hey, we're selling this entire practice. And it's not just here in Rochester. It's also in Buffalo, too. And, oh, by the way, your parents belong to that same whole medical group. So they've lost their doctors as well. But these doctors are now all going to new medical groups in all different locations. So you can either get yourself a new doctor, again, because this is the third time that something has happened to my primary care doctor in the course of my lifetime of weird health problems. You can get yourself a new doctor who doesn't know anything about you and have all your records transferred again, and hopefully they don't get lost. Or you can keep your current doctor in this new location way on the other side of town. And then try to get in to get an appointment. And we highly recommend that you do that soon because there's 5 times as many patients at this new practice. And maybe we'll see if we can take care of you. I mean, to me, this is a pretty piss poor way to be trying to take care of people who potentially need more than once every 5-year physical. And I used to actually go, when I was young, I used to actually go every single year, and I'd get my blood tested, and I'd get my physical, and get all my swipes and whatever. I was really good about it until I had, well, I don't know. I don't want to get into this. This wasn't about this. Let's get back to the brain. So anyway, I came across a story yesterday that was titled, Non-invasive optical sensors provide real-time brain monitoring after stroke. Now, I usually point out in titles like these how they use these non-invasive scanning technologies to cure you or to make you better after an illness. This is why this medical march forward is so important. They're using this to get these tools onto and into our bodies to be able to draw a baseline and then put it into the database and then use that to draw some sort of statistics and dashboards so they can tell whether or not you're operating within parameters. But what caught my attention about this and why I even got a little bit excited is because the other alternative right now that you have for brain monitoring after stroke is to be loaded up with that gadolinium, which is that chemical they typically give you intravenously. Then they put you into the MRI scanner and they scan you, and they're able to then get some real-time images of it pumping through your body and all your different blood flow rates and widths of arteries that they can measure in high resolution. Let's read this. What is gadolinium? That's what it is. Gadolinium. Gadolinium is one of 17 rare earth elements, and it is part of the lanthide series of metals. Most rare earth metals are toxic to humans, and gadolinium has paramagnetic properties, and that means that when it moves through a magnetic field, such as an MRI, its temperature increases slightly. And this makes it useful to enhance the image quality of MRI scans. Gadolinium is highly toxic to humans. Oh, so let's put it intravenously into a sick person's veins. While gadolinium has no known biological properties and is not found naturally in the human body, its molecules are similar in size and shape to calcium, which has many biological functions. Yeah, calcium is pretty damn important. And because free gadolinium ions mimic calcium in the human body, and I'm going to go back to some of that brain switch flipping that we had talked about in the past, using those calcium ions, it can interfere with the effects of calcium-dependent processes in the body. Oh, really? Gadolinium can cause a host of toxic effects, including inflammation, oxidative stress, neurological damage, and damage to our genes or our DNA. The damage to cells from gadolinium is exacerbated by exposure to magnetic fields in the MRI scans. So wait a second here. Now I've had 4 of these MRIs with gadolinium, as well as an angio where they loaded me up with some sort of contrast. How does that affect me in the long term? Well, I gotta say, I definitely have been feeling a cognitive decline over the last 6 or 8 months, and it's really beginning to worry me. So, all right, so where do we go from here? First reports of gadolinium contrast toxicity. Now, my best friend's dad, back probably 8 or so years ago, passed away after getting an MRI. And I spoke to him while he was on dialysis, and he was on dialysis for about a year till he ended up with sepsis by getting an infection. But he had told me many, many, many times over and over again, do not get the contrast dye in an MRI because it's what killed my kidneys. Put him into stage 4 kidney failure. He said, well, listen to this. First reports of gadolinium being associated with fatal disorder called nephrogenic systemic fibrosis were published in April 2006. And in 2007, the FDA requested gadolinium contrast manufacturers place a black box warning on all gadolinium contrast products. A black box warning is the strongest warning that the FDA uses in pharmaceutical packaging, indicating that a particular product poses a serious health risk. And at that time, in 2007, the risk was only thought to affect patients with kidney disease or damage. Well, guess what? It affects more than just that. Well, new evidence of gadolinium accumulation now comes to light. Report of long-term gadolinium accumulation in patients with normal kidney function following gadolinium-enhanced MRI scans first started to appear in 2009. It was shown that gadolinium could be found in the bones of patients who underwent gadolinium MRI scans every 8 years. And since 2009, many new reports have begun appearing in medical literature showing that gadolinium accumulates not only in your bones, but also in particular areas of your brain, even though we didn't think that it crossed the blood-brain barrier. And in all these cases, the patients all tested for normal kidney function. In a 2016 review article by MedInsight researchers, all the consolidated known and assumed toxic effects of gadolinium appeared, and I think I have that article up here somewhere. This article reviews the studies showing that gadolinium was toxic to the kidneys, liver, brain, white blood cells, and it does DNA damage. So put on a seatbelt. This is just crazy because millions of people have had MRI scans with this contrast. In a 2016 landmark article published by Dr. Richard Slominka and the colleagues of the University of North Carolina, Dr. Slominka, long considered amongst the greatest experts in MRI contrast safety, coined the term gadolinium disposition disease. And according to the authors, gadolinium disposition disease is named, the name is proposed for a disease process observed in subjects with normal or near normal renal function who develop persistent symptoms that arise hours to 2 months after the administration of gadolinium-based contrast agents. And in these cases, no pre-existing disease or subsequently developed disease of an alternate known process was present to account for the symptoms. Typically, clinical features of gadolinium disposition disease include persistent headache, bone and joint pain, clouded metation, which is often described as brain fog, and soft tissue thickening under the skin. Patients may also complain of tightness of the hands and feet that resemble the feeling of being fitted with extremely tight gloves or socks. And patients may also experience excruciating pains in the arms and the legs, but they also may be in the torso and the generalized locations. This pain is often described as feeling like sharp pins and needles or cutting or burning. The research concluded that we've proposed naming this histopathologically proven presence of gadolinium in the brain tissue as gadolinium storage condition, and we describe a new entity that represents symptomatic disposition of gadolinium in individuals with normal renal function, for which we propose the designation of gadolinium disposition disease. So finally, in 2015, the FDA announced that it was evaluating the risk of gadolinium accumulation in the brains of patients who have undergone repeated exposure to gadolinium-based contrast agents. And as of March 2017, almost 2 years later, the FDA had not updated their guidance about using gadolinium in MRI scans. Now, let me just back up here for a second, because my incident was at the end of June of 2017, March, April, May, June. 3 months later, you don't think that somebody in a laboratory would have felt the ethical need to at least inform me at some point, or maybe the hospital put it in writing and have me ink it even though I was half out of it, to say that I, consented to having 4 different scans within like a 3 or 4 days time of this contrast agent done to my body? Because I never signed up for this. And I'm a little bit pissed off at the moment. You know, my mother would say, oh, but they saved your life. Well, yeah, maybe. They probably did. I was kind of in bad shape there for a little bit. But the gadolinium didn't necessarily save my life. They could have still done an MRI scan without the contrast. It might not have been as high resolution as they wanted, but if there was a blockage, they should have still been able to see it. All right, so let's continue here, because this really got me fired up this morning. So the FDA calls for warning labels on gadolinium, September 11th, 2017. A medical imaging drugs advisory committee of the U.S. FDA voted 13-1 on Friday in September, with one abstention, for recommending adding a warning label to gadolinium retention for contrast agents used during MRIs. The new labels would warn that gadolinium may be retained in various organs, including the brain, after the use of these agents, with linear GBCAs having a greater risk than macrocytolytic agents. The warning would also note a greater risk in specific populations, including children and pregnant women. And during an all-day meeting, the committee heard from industry representatives, researchers, patients, and patient advocacy groups. And I had even heard about this one. Even Chuck Norris and his wife, who is suffering from a lot of adverse symptoms where her skin burns all the time. She's in excruciating pain, and they are suing these gadolinium companies for poisoning her. Regardless of the data, we should consider how these agents are being used and when they should be used and their appropriate dosage, says Peter Hershkovich, MD, acting chair of the committee and the director of the PET department in the National Institute of Health. Also, there was a lot of focus on the brain today, but we need to look inside and outside of the brain, which may require a large population study, and we need to also develop more in vitro data for humans and animals. So let's get back into that Petri dish, because it apparently seems that they did not do their due diligence before this was fully approved in humans. So gadolinium disposition ignores the blood-brain barrier, according to a study, and this was June 29th, 2017, which happened to be the day I had the stroke. Gadolinium disposition in the brain, and this is out of radiologybusiness.com. Gadolinium disposition in the brain may be worse than previously feared, bypassing the blood-brain barrier and landing in regions of the brain responsible for voluntary motor control. Oh, maybe I'll get that involuntary slapping mechanism. While no negative symptoms of disposition have been established, a study published in Radiology calls for an additional research into this concerning finding. Now, makes me wonder, when they did like over 3,300 scans from what I saw on the CD they sent me, during those 4 scans, they got over 3,300 pictures. Maybe I was part of a study, because I did have to ink a paper that says, well, yeah, I'll let you use my scans anonymously, of course, in a study if need be. So previously believed to be harmless and exit the body, a growing amount of evidence now suggests that this contrast agent can remain in the patient's body for years, triggering the European Medicine Agency to pull a handful of gadolinium contrast agents from the European market. And while the exact mechanics of this disposition are not well understood, let's just keep giving it to patients. It was believed that gadolinium contrast would not cross the blood-brain barrier. However, much of the research into the disposition involving patients with intracranial abnormalities that could possibly compromise a barrier, which would be the function of the type of patients who are receiving gadolinium-enhanced contrast examinations in the first place, like people who come in for a potential stroke. Leading researchers Robert J. McDonald, a staff neurologist at the Mayo Clinic in Rochester, Minnesota, has seen slivers of evidence pointing toward this contrast material circumventing the blood-brain barrier. However, his suspicions have never quite been confirmed in a full study, and to that end, he and his colleagues examined post-mortem tissue samples of patients who underwent enhanced MRI exams. They found that the gadolinium deposits of various sizes in all 5 patients with presumably intact blood-brain barriers, indicating a misunderstanding of the blood-brain barrier. What? So they don't even quite understand the blood-brain barrier, but let's keep injecting this shit. Our results suggest that our current thinking with regard to the permeability of the blood-brain barrier is greatly oversimplified, as gadolinium appears to accumulate even among patients with normal brain tissue and no history of intracranial pathology. Disposition was strongest in the areas of the brain prone to calcification, and that would be the globus pallidus and the adenate nucleus, according to the study. This observation could be interpreted as evidence that these neuroatomic regions have less robust capillary basement membranes, or that this disposition is a consequence of the localization to the areas of the brain that are susceptible to cellular stress. Reassuringly, they detected no pathological changes in the tissue samples with disposition, staving off fears of cytotoxicity for now. It does say for now. However, they did find that gadolinium deposits in the nuclei of neurons raise questions about DNA damage to your brain. And although no clinical phenotype appears to be associated with our patient cohort, the expected physiological effects and the clinical significance of this metal disposition within neuronal tissues are unknown and merit additional investigation. While the study cohort was relatively small, the results show that gadolinium disposition occurs regardless of intracranial abnormalities. And this as yet unknown method of disposition could be affecting tens of millions of patients worldwide, wrote McDonald, and more research is needed to investigate any comorbidity. Well, Reading this story really made me start to think I better get my ass into my neurologist's office and start reporting the fact that I've been experiencing what I am calling some sort of neurological decline, at least from 8 months ago. And the funny thing is that I was blaming it all on post-stroke, but it sounds to me that maybe it could be a little bit more, and it's beginning to piss me off. But I think I better get on record, because it sounds to me with tens of millions worldwide, that would be a really good cause for some sort of class action suit. All right, but I didn't say that, but I'm mad enough to maybe even go to that extent. So this is out of Dr. Mercola now. And this is an older story, which surprises me because it seems that there have been concerns for quite a while. January 9th, 2014. So it took the FDA 3 more additional years to come to the conclusions that, whoops, there's a big problem, Clyde. Gadolinium, the MRI agent linked to brain abnormalities. What? Yeah, just what I needed. More brain abnormalities. Magnetic resonance imaging is one of the better choices if you need a diagnostic imaging procedure performed, says Dr. Mercola. And unlike CT scans or X-rays, an MRI does not use ionizing radiation that may cause DNA damage or cancer. Though I was reading that high-end magnetic fields could still also disrupt cellular processes and cause issues as well. So none of this stuff is absolutely safe. And of course, you got to look at how desperate you are to be cured. Though I don't think I had much of a choice in this matter, but I would have liked to have been informed that there were some concerns about this contrast agent that they were pumping into my bloodstream. But instead, a strong magnetic field and radio waves produces cross-sectional images of your organs and other internal body structures. And in some cases, however, a gadolinium contrast medium is used to make the images clearer, and this is typically called an enhanced MRI. That's what I'm saying. I'm hoping that some of these new high-resolution MRI scans aren't just using higher frequency magnetic waves to do more damage, but are actually doing something good and allowing them to get rid of this contrast. There are risks involved when contrast agents are used, and that includes potential brain abnormalities revealed by a new study, and this is back in 2014. So it is important to use extreme caution and only to get an enhanced MRI if it is absolutely necessary. Gadolinium is a paramagnetic metal ion that moves differently within a magnetic field. And when used during an MRI, it may make certain tissues, abnormalities, or diseases more clearly visible. However, because gadolinium ions are known to be toxic, it is chemically bonded with a nonmetal ion when used during MRIs to allow it to be eliminated from your body before it is released into your tissues. Well, for the very first time, a new study back in 2014 has shown that gadolinium may not be immediately eliminated, and it may instead persist inside of your body. The study compared brain images of patients who had undergone 6 or more contrast-enhanced MRI brain scans with those of patients who had received 6 or fewer unenhanced scans. And I might add that they had given me a few different MRI scans for sinus issues and things in the past, so I've had more than 6. It revealed areas of high intensity or hyper intensity in 2 brain regions, which are the detinous nucleus and the globus pallidus, which correlate with a number of galadium-based enhanced MRIs. It is unknown at this time what hyperintensity may mean. However, hyperintensity in the detinant nucleus is associated with multiple sclerosis. What? And it is now being suggested that this hyperintensity may be the result of a large number of enhanced MRI scans often received by multiple sclerosis patients. Hypersensitivity of the globus pallidus, meanwhile, is linked with liver dysfunction, and the study's lead author noted hyperintensity in both of these regions of the brain on unenhanced MRIs may be a consequence of the number of previous gadolinium administrations, because gadolinium has a high signal intensity in the body. Our data may suggest that the toxic gadolinium components remain in the body even in patients with normal renal function. Among patients with severe kidney disease, the use of gadolinium-based contrast agents is linked to the development of that nephrotic systemic fibrosis, which was first identified in 1997. And while its cause is still unknown, it has only been reported in those with kidney disease. It causes a skin thickening that can prevent bending and extending your joints. It can also develop in your diaphragm, your thigh muscles, your lung vessels, and your lower abdomen. And along with causing decreased motility of the joints, it can be fatal. And because of this connection, the U.S. Food and Drug Administration requested that manufacturers of all 5 gadolinium-based contrast agents add a boxed warning and new warning sections to their labels to describe the risk of developing this necrotic disease. I recommend everyone use caution with gadolinium-based contrast agents and only use them when absolutely essential. Even if you're healthy, these contrast agents may cause side effects like life-threatening allergic reactions, blood clots, blood vessel irritation, skin reactions, including hives, itching, and, oh yes, facial swelling. However, if you have kidney disease, using caution is particularly important. Often the use of contrast agent is optional, and an acceptable MRI may be conducted without the use of a contrast, except when you have a neurologist like mine who got all pissy when I told him I was allergic to it and never called me back to check up on me or decide to do any other type of scan. If you have been administered a gadolinium-based contrast agent and you have kidney disease, be on the alert for the following symptoms and contact your healthcare provider immediately if you experience any of them. Swelling, hardening, and tightening of your skin, reddened or darkened patches of skin, burning or itching of your skin, raised yellow spots on the whites of your eyes, stiffening of your joints, problems moving or straightening your hands, arms, and legs, and pain deep in your hip. Hey, I've had that one. Or in your ribs. And as mentioned, MRIs are preferable to CT scans because they do not use ionizing radiation. However, it is still wise to minimize their use as much as possible, in part because of the effects of exposure to MRI's strong magnetic field are still largely unknown. Research has shown that there are biological effects in the human body, however, including to the retina, the pineal gland, and some cells in the paranasal sinuses. Time-varying magnetic fields may also interfere with your cellular nerve function and muscle fibers, while MRIs also produce acoustical noise, which has been known to cause temporary and rarely permanent hearing loss. Wow. Finally, due to the strong magnetic field produced, an MRI can become deadly if metal objects in the room are not properly secured. And I just saw a story recently about that. Someone who got killed by something flying toward him when he was in the MRI. And if you have medical devices such as a pacemaker, well, they can get ripped right out of you. There's at least one report, and I read about a second one in the UK, I think, about someone being killed during an MRI due to an unsecured metal oxygen tank. All right, so where do we go from here? So this is one I caught the other day that made me think about the gadolinium I had been administered, because I've also been noticing not only has it been hard for me to focus and to multitask recently, but I've also been noticing that my eyes, I almost think I have to go again for glasses because my eyes have been doing a lot of squinting, and they seem to be highly sensitive to reading on a screen. When I come out here, I actually had to dim my other monitor the other day because it was making me feel almost blind, make my eyes get all jumpy. Listen to this. This is again out of Radiology Business. Is the eye the window to the brain? Well, how gadolinium is changing the field of cerebrovascular imaging. Yeah, it's screwing you up. Gadolinium could be doing a lot more for cerebrovascular patients than previously thought, and that would be someone like me. According to a group of researchers at the National Institute of Health, The chemical agent could highlight not just abnormalities in a routine brain MRI, but also identify the severity of incident strokes. They're going to actually try to put a happy spin on this. Gadolinium has long played a critical role in clinicians' understanding of the pathological process, and that would likely continue to be the case, says senior author Richard Lee, who wrote in Neurology this week. And this is February 9th of this year. Though the chemical might be commonplace in the clinical setting, Lee says the ties between the agent, your eye health, and stroke indicators was surprising. Yeah, because they give this to people who have had strokes. We suspect that there may be a link between a stroke and the eye, Lehigh told Radiology Business. However, to find that the eye was informative about the stroke was exciting, he says. Yeah, not the fact that we just poisoned all these people to find that out. Gadolinium is routinely administered in imaging procedures to expose the brain abnormalities during MRI scans. And in a healthy patient, the chemical is filtered out of the bloodstream through the kidneys, which is a lie, we find out. In those who have experienced damage to their blood-brain barriers, which we've just found out they don't really understand that, it leaks into the brain, drawing attention to brain damage and highlighting problem source areas. We've been conducting large observational natural history studies at the NIH for many years, which we collect serial brain imaging on stroke patients to learn more about the disease. So ding, I did become a part of a study. When reviewing the images from the study, we noticed that there was leakage of gadolinium into the eyes. Yes. So not only is it in areas of your brain and between your neurons and causing DNA damage, no, but it also got into my eyes. And it has prompted us to construct this investigational study to better understand the phenomenon. Lee and his team performed MRI scans on 167 stroke patients upon admission to the hospital, just like they did to me, withholding gadolinium from the initial test, the study stated. And yeah, they did both on me. I had with and without, and then compared the study results to those fresh MRI scans taken 2 and 24 hours later with addition of gadolinium. Well, that's funny, because then they did do mine the next day, and they told me it was to compare and contrast. And about 3/4 of the patients experienced gadolinium leakage into their eyes during testing, the authors reported, and 2/3, 66%, showed leakage in the 2-hour scan, while 75% presented leakage at the 24-hour MRI. You know, I also wondered why, when they did the write-ups on these scans, they looked at every single organ in my body and did a full-blown write-up on every single organ that they were looking at. There was an element of surprise surrounding the initial observation, given that it had not been previously described, said Lehigh. However, we carried out the study to explore the findings in more detail, and the surprises kept coming. Oh, it was so exciting. Real-time guinea pigs. I did not anticipate that this process occurring in the eye would be so revealing about acute and chronic cerebrovascular disease of the brain. The distribution of gadolinium within the eye varied between MRI scans, and in patients who showed traces of the chemical at the 2-hour mark, gadolinium was present in the frontal area of the eye, known as the aqueous chamber. And at the 24-hour scan, gadolinium seemed to migrate toward a patient's vitreous chamber at the very back of the eye. According to Lehigh et al. Study, stroke patients who recorded gadolinium in their vitreous chamber at the 24-hour mark were more likely to be older, have a history of hypertension, and have more white matter hyperintensities, which are linked to decreased cognitive function of brain aging in their MRIs. So I probably didn't have too many of those before this study. The key findings are that the focal process in the brain, specifically the stroke, appears to have a remote effect on the eye, and this supports the concept that stroke has both local and diffuse effects on the body. And from a technological perspective, these findings suggest that there may be a way to evaluate stroke in the eye as part of an as yet not developed technology. The concept is promising, he said, and clinicians' next step will likely be moving to a contrast agent that can be visualized without an MRI. And gadolinium is transparent and does not harm a patient's vision that we know of yet, but it does require large-scale testing like an MRI to be effective. Lehigh said that before anything else can happen, the research team needs to confirm the current results with a prospective study including both control subjects and patients with disorders beyond stroke, such as multiple sclerosis. Such a study would incorporate systemic examination of the eyes and vision, and in addition, modern ophthalmological techniques that might confirm the breakdown of the blood-ocular barrier, including optical coherence tomography, and that would be an OCT, and fluorescein angiography could be applied. The result of such a study would aim to determine which ocular evaluation can provide sensitive and specific measures of the stroke. Now, I actually, after we get here, and I don't know where I moved this story. Oh. Well, here we go. Non-invasive optical sensors provide real-time brain monitoring after stroke, dated 2 days ago, February 21st, 2018. And I thought this actually was quite interesting. Each year, nearly 800,000 people in the U.S. experience a stroke, and almost 90%, hold on, I'm going to cough. Sorry about that. Almost 90% of those are ischemic strokes in which a clot cuts off blood flow to a part of a brain, and that's what I had. To further prevent injury, blood flow of the brain must be restored as quickly as possible. And in a new study, researchers showed that non-invasive optical sensors can provide clinicians with real-time feedback on whether or not clot-busting treatments are restoring blood flow. And that's what they did. They just pumped me full of anti-clotting agents, and there were 2 or 3 of them, and they just kept them flowing for days on end and kept my blood pressure high, hoping it would blast out the clot. Apparently it did. The technique, which monitors blood flow and oxygen levels in the brain, could also reveal early warning signs of neurological complications after a stroke. We hope that providing individualized management of stroke patients with novel optical monitoring systems, such as the one we developed, will improve the chances of recovery and consequently reduce the direct healthcare and socioeconomic burden of these people to our healthcare system. In the Optical Society's journal called Biomedical Optical Express, the researchers report on a field test to their new compact and user-friendly optical sensing system, which is designed for clinical use in hospital emergency departments. They demonstrated that their system can be used at the bedside of a stroke patient to detect in real time the effectiveness of a clot-busting drug to improve blood flow of the brain. The potential impact of this new approach is quite significant, since stroke is the leading cause of long-term disability in adults worldwide, and the efficacy of this treatment depends on achieving a rapid restoration of blood flow to affected parts of the brain. Currently, most clinicians assess blood flow in the brain by using measurements taken at a single point in time with an MRI or a CT or both. And these measurements are usually performed at the time of emergency department admission to help guide a doctor's treatment decisions. Although a method called transcranial Doppler can perform continuous monitoring, it only measures blood flow in the large vessels, and doctors must undergo special training to learn how to use it and to interpret its results. Well, this new optical monitoring approach provides a continuous measure of blood flow in the brain's micro vessels, not just the big ones, which directly provide blood to the brain tissue. And it also creates a portable and suitable for continuous measurement environment for cerebral blood flow at the bedside of the patient without the need for technical expertise. The optical monitoring technique is based on diffuse correlation spectroscopy, which determines blood flow by analyzing fluctuations of dark and bright spots or speckles produced by laser light traveling through tissue, which is right across your forehead, including your blood vessels, and combining this diffuse correlation spectroscopy with near-infrared spectroscopy. It adds information about the amount of blood in the brain tissue and how much oxygen it carries. So I'm thinking it's almost like one of those little finger things that they put on you to see what your oxygen level is in your blood. Combining these two types of spectroscopy was developed at the University of Pennsylvania in the 1990s, and later at the Photonic Sciences Institute in Barcelona, Spain. This current group developed user-friendly devices that have allowed the technology to be used as a research tool in hospitals and healthcare centers around the world. So bringing what was previously a research instrument into the clinical setting of an emergency department requires researchers to adapt the system for a fast implementation. So they tested optical monitoring systems on 5 patients admitted to the emergency department with an acute stroke and who were treated with tissue plasminogen activators, which is a drug that dissolves the clot to improve blood flow. They used the system while the treatment was administered and then followed its effects on blood flow and oxygenation. And with this optical monitoring, we detected the increase in cerebral blood flow and oxygenation caused by the treatment in real time. And the increased blood flow detected with the new system correlated with the opening of the blocked artery seen using transcranial Doppler and with improvements in neural deficits. Now, I'm going to say that if that's the case, this sounds to me like a potential future treatment that could be used instead of whatever that shit's called, the gadolinium contrast and an MRI. And it looks a little bit scary. It looks almost like it came out of a Clockwork Orange movie where it's wrapped around your forehead with all these wires sticking off of it. It's got these little lasers that right through your skin and your brain tissue, or brain cranial tissue, so it can actually see some of the blood vessels underneath. I thought that was kind of interesting as well. All right, so where do we end up here? Well, don't worry about it because all of this is coming to understand the brain. We came across, actually, there were a couple different stories here, and I don't know, we got a couple minutes. This one got my attention the other day, February 14th, 2018. Tissue paper sensors show promise for healthcare, entertainment, and robotics. Engineers have turned tissue paper, which is very similar to toilet paper, they had to point out, into a new kind of wearable sensor that can detect a pulse, a blink of an eye, or other human movement. The sensor is light, flexible, and inexpensive, with potential applications in healthcare, entertainment, and robotics. University of Washington engineers have turned tissue paper into a new kind of wearable. And this technology, described in a paper published in January in the Journal of Advanced Material Technologies, shows that by tearing tissue paper that is loaded with nanocomposites and breaking the paper's fiber, the paper acts as a sensor. It can detect a heartbeat, a finger force, a finger movement, an eyeball movement, and more. And the major innovation is a disposable, wearable sensor made with cheap tissue paper. And when we break the specimen, it works as a sensor. These small Band-Aid sized sensors could have a variety of applications in various fields. For example, monitoring a person's gait, which they can identify you by in surveillance footage, or by the movement of their eyes, or it can be used to inspect brain function or a game player's actions. The sensors could track how a special need child walks home in a home test, sparing the child the need for a hospital visit, or the sensor could be used in occupational therapy for seniors. And in their research, scientists used paper similar to toilet tissue. The paper is nothing more than a conventional paper towel, and it is then doused with carbon nanotubule-laced water. And the carbon nanotubules are tiny materials that create electrical connectivity, and each piece of tissue paper has both horizontal and vertical fibers, so when the paper is torn, the direction of the tear informs the sensor of what has happened. To trace an eye movement, they are attached to a person's reading glasses as well. The work has so far been contained in a laboratory, but they are hoping to find a suitable commercial use, and a patent was filed in December of 2017. So now, last step but not least, we had read about some sort of graphene now being able to be embedded in the brain to be able to get measurements, and that it was biocompatible. Well, a brand new expert besides Elon Musk or Stephen Hawking has come out and said that AI will be billions of times smarter than humans, and man needs to merge with it. And this was just recently again, February 21st, 2018, so step up with your brain scan. Artificial intelligence could be millions or if not billions of times smarter than humans soon, and people may need to merge with computers to survive, says futurist to CNBC. Speaking on a panel hosted by CNBC at the World Government Summit in Dubai, Futurizon's Ian Pearson's comments mirrored ideas put forward by CEO of Tesla, Elon Musk. The fact that AI can go further than humans, it could be billions of times smarter than humans are at this point. So we really do need to make sure that we have a means of keeping up. Well, right, if you hadn't done all this brain damage to people with this gadolinium contrast dye already, maybe we wouldn't need these brain implants to fix us. The way to protect against that is to link that AI to your brain so we have the same IQ as a computer. And I don't actually think that it is safe, just like Elon Musk says, to develop a superhuman computer till we have a direct link to the human brain so we don't get way ahead of ourselves with artificial intelligence. And there we go, guys. Happy Friday to you all. Well, make sure you take care of yourselves. Do a little bit of reading.